Right, good morning. This video is going to be a little lengthy. I'm just going to tell you that right now, but it's the reason it's that way is because I'm covering all the notes. I don't want y'all to miss anything. So yesterday I attempted to start this lesson here and move on, and I just couldn't do it. I got the first part done here, but I couldn't get my document camera to work. It's working now, so we're gonna dive right into this. All right. First of all, it says given the triangle RST, and it has a little squiggly right there, and then it says triangle ABC. And the first thing I'm going to make note of is that this is similar. That means similar. So it tells me that one triangle is similar to the other, and find the lengths of each of the missing sides. Well, as yesterday we discussed, if they're similar, how do I know that they're similar, and how am I going to be able to find each side? And first of all, which is my image and which is my pre-image? Because last week we based things on finding scale factors, and that scale factor was determined by what's my pre-image and my image. Well, I'm just going to go with basic language. In basic language, in the sentence, RST comes first. So RST would be my pre-image, because that comes before, and my image would be after. So in this case, the figure got smaller. So if the figure gets smaller, that's a reduction. And remember, how do I find scale factor? Scale factor is determined by a ratio. First of all, scale factor is a ratio or a fraction. That's determined by taking a side in the image and dividing it by a corresponding side in the pre-image. Well, what two sides do I know? I know this top side in my pre-image, and I know this longer side in my image. Well, maybe to some of you that might look a little confusing. So what we did yesterday was we took some time and we went ahead and we took this and we orientated it the same way as the pre-image. All right, so I'm just going to go ahead and do that. Basically, I'm taking this and I'm kind of flipping it up, where this would be C. A has to be over here in this corner because A has to correspond to R, and then over here would be B. And then I can go ahead and label the sides. I can label this 8. I can label CB or BC 6. Now when I go to compare, yeah, it did take a little bit of time, but now when I go to compare, 8 to 12, 6 to ST, CA to 6. So now create that scale factor. But remember, it's the image divided by the pre-image. So it's 8 image divided by pre-image divided by 12. And what is 8 over 12 reduce to? It should reduce to 2/3. That means, which makes sense because my image got smaller. So this smaller image is 2/3 the size of the larger one. So how does that help me find my sides? Well, again, here's a review on how we set up our equations. We take a side in the pre-image, we multiply it by the scale factor to get the side in our image. So what is the side in our pre-image that we want to find? We want to find ST. So I'm going to go ahead and label that ST. I'm going to multiply ST by my scale factor, which is 2/3, and that ought to be equal to 6. Now, this is simply a one-step problem. It's not that complicated. I've got to get rid of the fraction, though, and everybody says, I don't like fractions. I hate fractions. You know what? Hate them. Go ahead and hate your fractions. That is absolutely fine. But you know what? You need to learn how to deal with fractions. They're not that complicated. Right? They're only complicated because you think they are. Here is ST times 2/3 and equals 6. What number times 2/3 is 6? Well, this is a multiplication problem. So I undo multiplication with divide. Think of it if it said ST times 3 equals 6. You would divide by 3, right? But the problem is this is a fraction. Well, guess what? This one's a fraction as well. When I'm dividing by 3, I'm actually multiplying by the reciprocal, which is 1/3. So multiply by 3 over 2. If I multiply the left side, I got to multiply the right side, and the fractions cancel out, and I'm left with ST, which is what I want. 6 is a fraction. 2 goes into 6 3 times. 3 times 3 is 9. Now, does that seem like a reasonable value for ST? Well, compare the corresponding sides. If you compare the corresponding sides, sorry, I got to move the camera again. In the pre-image, it was 9. It ought to be smaller in the image because the image got smaller. 9, 6, yes, it makes sense. Now we get to create one more. I gotta find AC, but remember, you go from the pre-image to the image. So over here, I'm gonna say 6 times my scale factor, which is 2/3. This always works. Pre-image times my scale factor should equal the image. The image is a C, because it's not labeled XY. Now, multiply. 3 goes into 6 twice. 2 times 2 is 4. So 4 is equivalent to segment AC. That's just a rundown of how we redo that. Now, the next segment, again, I told you this is going to be a little lengthy here. It says, given ABC, use midpoint M as the center of dilation. So now we're going to learn how to dilate figures, right? I got to do some camera adjustments here, and I'm gonna kind of show you. I'm trying not to get the shine in the screen there. So right there, right? And this is how we're going to do this. You're going to have to pay attention. You need a ruler or a piece of paper, a small piece of paper. In class, I used a small piece of paper. All right? And this is how we're going to do this. It's pretty easy. So here's your paper that you have in your book. Take your piece of paper, and you're going to fold your piece of paper or use your ruler. So basically all I'm doing is using this piece of paper as a ruler. What I'm going to do is I'm going to go ahead and I'm going to place a mark on the corner here and call it M. And that mark is where I'm going to place on M, and I'm going to line it up with point A on my triangle here, and I'm going to draw a light line. Not a real heavy one, but I'm going to draw a light line. So there's my light line right there. Remember, this is a dilation. It needs to be 3 times the size. It says right here on your paper, factor by a scale factor of 3. So it's got to be 3 times the size. Well, how do I determine how it's 3 times the size? I determine that really easy by noting M to A. So here's M to A. And now I'm just going to triple that movement. If this is M to A, this segment is once. There is 2 times the size, M to A, and here is 3 times the size. So that's A prime. So M, A tripled in size. There's 1, 2, 3 segments right there. And then I got to repeat the process for M to C. So I'm going to go M, I'm going to line it up with C right here. Again, draw a light line. Make sure you draw it out in space because you have no idea where C is going to be. And I'm going to go ahead and I'm going to draw M to C. I'm going to notate where C is. So all I'm doing is getting the distance from M to C. There's 1 along my line. There's 2. There's 3. There's C prime right there. All right? And I got to repeat the process with B. So yes, I'm going to repeat this process with B. Again, draw a light line. I'm going to go from M to B. Make sure I drew my line. I did. There is B. So now I'm keeping track of where A, B, and C are. Make sure this is in the camera. Again, I'm keeping track of where A, B, and C are. And I want to triple that. Make sure my line is long enough. There's 1. Making a little mark. There's 2. Oop, I need to make my line a little longer here. So making that line a little longer. There was 2. Here is B prime. Now I have A prime, I have C prime and B prime. So all I need to do is connect the dots here. So I'm going to connect C to B. I'm going to connect B to A, and so on. And if you need to pause this, pause it, come back, okay? And there. Now, what you should notice is that this figure is 3 times the size of the original one. What you should also notice is AC is parallel to A prime, C prime. CB is parallel to C prime, B prime, if we did this correctly. All right? It says now, use point N as the center of dilation with the scale factor of, hey, you need to make sure you pay attention right here, a scale factor of 12? No, that's 1/2. Okay? That's 1/2. We're not going to do that. So what we need to do here, how I do the 1/2, I'm going to go A, B to C from N. All right, so try and fit this in from end. Sorry, move this. I'm going to draw my line from end to A, end to B, end to C. There's my 3 lines. Now, I want this triangle to get smaller by half. Okay? So how do I get it smaller by half? Well, if we enlarged these, my other one, if I went 1, 2, 3, how do you think I take this and cut this in half? Find the midpoint of this line. So where is AN? Where is half of AN? Half of AN is about right there. Half of CN is going to be just about right here. And half of NC, again, going to be in the middle. And then what you should see again, you should see that these 2 lines are parallel. Mine aren't quite parallel, right? These 2 lines should be parallel, and A and C, they should be parallel. It got small, okay? So it should be by a half. Now, the next thing it wants us to do is it wants us to label vertices in 2 triangles you created in the diagram above, okay? So we labeled the vertices, we did that as we went through, and it wants us to create some proportions. If we go through my list of proportions, what does it mean by proportions? What it means is it means it wants us to compare and list, like corresponding sides, AC to A prime C prime. So that would be one proportion. And how we do that is AC over A prime C prime. That would also be equal to, now we're going to compare a couple other corresponding sides, BC to B prime C prime. So I'm going to list that again. So BC to B prime C prime. That's how we're going to do that. And then we could just keep going. All right. Now it also wants us to create a couple proportions from down here. So you can pause and go ahead and do that. And then the next thing it has us go through, I'm just going to use the screen here. It has us say, okay, under what conditions are corresponding line segments in an image and pre-image parallel after a dilation? Well, guess what? I'm going to go back to after a dilation, they were all parallel. Corresponding sides were always parallel. So this is why I have always circled. Now, give reasons for your answer. Well, the reason for that is after each dilation, the segments were different sizes, but they had the same position. That's one example. So I'll go ahead and show you here on number 5. As we dilated it with a scale factor of 2, how would I have done that? All right, but AC is in the same position as A prime C prime. All right, no problem. But how would I have done that? Well, we can actually use the other side of my figure here. And since it wants me to dilate at A, there is A, here is C, and it wants me to double that. Well, what's twice that? Gee, I move A to C, and boom, this obviously is a little bit bigger. So there would be, there's A prime C prime. I didn't use the ruler when I did this, I just kind of guessed. Right? I'll actually do this legitimately and make it look more reasonable. There is C prime. Now we do the same thing with B. Got to label that C. So I'm going to come here for A, come down here for B, and I double it. A to B. There is B prime, and use my eraser. That, sorry for that. And then now I can just kind of connect these two, and we double that. So notice AC is in the same position A prime C prime is. Those two lines are parallel. Even this right side here, those two segments should be parallel if you did them correctly. Mine's off just a tad, but if we do them accurately, they would be parallel. Now, question 6 at the bottom. This is the last thing. I know this video is long, and I hate long videos, but here's the last thing. It says, explain in the diagram how you created the following theorem. The segment, and we'll use BC in the diagram above, joining midpoints BC. This is where I want to make sure you understand. Okay? It says the segment joining the midpoints. So this segment here, okay, or rather this segment BC joins the midpoints. C is a midpoint of A prime, C prime, and B is a midpoint of A, B, or A prime, B prime. So B is in the middle of this hypotenuse, C is in the middle of this other side. BC joins at the midpoints of two sides is parallel to the third side in half the length. Why is BC parallel to this third side? Well, you should notice angle C as we moved it out didn't change. Angle B as we moved it out didn't change. If these two angles are congruent, these lines must be parallel. The same thing here. If these two angles, angle B and B prime, are congruent, these two lines are parallel. They have to be parallel. These would be classified as corresponding angles. Okay? Conversely, if the lines are parallel, we know that B and B prime are congruent, or C and C prime are congruent. So it kind of goes back and forth. All right? So there's your notes for today. Sorry for the long video.